jet target aircraft, designed, manufactured, and field serviced by Teledyne Ryan, are used by nearly every defense system in the free world. These targets range from the subsonic Firebee 1 and the supersonic Firebee 2 turbojets to the Mach 2 Firebrand ramjet anti-ship missile target. Over the past 30 years, Teledyne Ryan has also developed a comprehensive family of remotely piloted vehicles, which, together with target aircraft production, accounts for the company's distinction as producer of more jet-powered aircraft than any other manufacturer in the United States. The cornerstone of Teledyne Ryan's acknowledged leadership in unmanned aircraft technology is the Firebee 1 subsonic jet target. Over nearly 30 years, Firebee has not only proven itself to be a highly reliable aerial target for the U.S. Army, Navy, and Air Force, but has also evolved into a sophisticated target system used to test air-to-air, and surface-to-air defensive equipment and personnel the world over. To date, more than 6,000 Firebees have flown over 30,000 missions, with a mission reliability factor in excess of 92%. Many under very stringent environmental conditions. One U.S. Air Force Firebee flew 87 missions over a 3-year period. A squadron of Firebees made 65 consecutive flights without an operational loss. The target's rugged design accounts for a large share of this durability. Firebee's 5 major airframe components, fuselage, wing, nacelle, empennage, and tail cone, are all detachable with self-aligning bolts for ease in handling and maintenance. With an overall length of about 7 meters, wingspan of just under 4 meters, and keel to rudder height of about 2 meters, Firebee is capable of payloads up to 455 kilograms. Firebee's performance envelope includes a maximum speed of Mach 0.95 at 15,000 meters, a maximum altitude of over 18,000 meters, and a maximum endurance mark of almost 2 hours in its standard configuration. The target can be launched from zero-length launchers, which are either stationary, mobile, or at sea. In these launch modes, Firebee engine thrust is augmented by a solid propellant rocket motor, which burns for 2.2 seconds before dropping away. Firebee can also be air-launched for greater flexibility in conducting remote testing or training activities. After launch, the target is controlled from the launching aircraft without need for ground facilities. For training flights, Firebee is operated with towed targets called towbees, which contain special radar or infrared augmentation devices. Infrared or radar-guided missiles then seek and destroy the relatively inexpensive Firebee rather than the Firebee itself, which survives to fly additional missions. Similarly, a radar-augmented banner tow is used for radar-directed gun evaluation. Firebee has flown over 2,000 missions against the Hawk and improved Hawk missile systems. At the present time, Firebee is the only target system in the world to be certified by the U.S. government for use internationally against both versions of the Hawk. The Firebee Toby configuration also flies against Red-Eye and Chaparral missiles and the M61 Vulcan and M42 twin 40mm guns. A major factor in Firebee's dependability history is its parachute recovery system, activated either automatically or by operator command. The target descends in a horizontal attitude at 20 feet per second to a ground or water landing for eventual retrieval by helicopter, land vehicle, or boat. The nacelle keel absorbs ground landing impact. While in water, Firebee floats until it's retrieved. A sealed compartment protects critical components. The Firebee system includes complete support equipment for ground handling, maintenance, and checkout, and is designed for flight turnaround in less than a day, even after saltwater recovery. Teledyne Ryan can either supply complete Firebee operational and field services anywhere in the free world, or can efficiently set up initial operations and train user personnel for eventual takeover. Firebee's highly modular design can incorporate a variety of realistic training or test missions, or provide a wide spectrum of realistic threat simulation through low-altitude flight, formation flight, and turns of up to 6 Gs with radar augmentation and infrared augmentation. Teledyne Ryan's reputation as a world leader in unmanned jet target aircraft led to its role in RPV, or remotely piloted vehicle development. Both RPVs and targets can be controlled in flight by a remote pilot. But RPVs can also fly pre-programmed course and altitude profiles without operator intervention. This capability permits a wide range of missions where risk to manned aircraft is high. early 60s, Teledyne Ryan developed the first operational unmanned photo reconnaissance vehicle from the company's Firebee 1 jet target aircraft. Teledyne Ryan has since produced over 900 RPVs in 30 different configurations to fulfill 3 basic mission requirements. Photo reconnaissance in both day and night and at high or low altitudes, electronic warfare including both passive and active systems, and gathering radar and communication signal intelligence. In addition, the capability for strike missions has been successfully demonstrated. Photo reconnaissance vehicle configurations are determined by the mission requirement. RPVs for high-altitude missions are characterized by larger wingspans and extended fuselage sections. Optional nose configurations house various high-resolution camera systems capable of day or nighttime infrared photography. One model uses a television camera to relay a real-time TV picture to a remote operator who can then navigate and steer the aircraft visually for greater accuracy or look for targets of opportunity.
So, Roger, on your recovery today, it's going to be practical.
Capable of altitudes above 18,000 meters and total ranges in excess of 2,700 kilometers, these reconnaissance vehicles have proven their ruggedness under the most demanding conditions and hostile environments. One RPV survived 68 missions before it was finally shot down by anti-aircraft fire over North Vietnam. Low-altitude photographic vehicles have flown below power lines in similar hostile environments and returned with vital reconnaissance information. RPVs engaged in electronic warfare are equipped with either passive systems, such as chaff dispensing pods, or active transmitters that generate noise or false targets over the enemy's radar band. Signal intelligence gathering RPVs collect and return or relay electronic intelligence data, called ELINT, or communication intelligence data, called COMINT, for subsequent analysis. On COMINT missions, the RPV flies along or over hostile territory and tunes into the enemy's tactical information and command channels. ELINT RPVs fly various high, medium, or low-altitude missions to collect unique missile beacon signatures, new or unusual signals and telemetry data, or develop an overview of an adversary's radar network by type, function, and location. Certain Teledyne Ryan RPVs have demonstrated strike capability with on-target delivery of the Spasm, the stubby Hobos television-guided glide bomb, and the Maverick television-guided missile. A multi-mission RPV system developed by Teledyne Ryan incorporates all 3 mission capabilities into one modular airframe for maximum flexibility and cost-effectiveness. Interchangeable payload nose modules and wing stores permit rapid in-field mission conversions for maximum inventory flexibility. A special purpose category of RPVs includes the Compass Cope R and the Mini RPV. Compass Cope is an advanced state-of-the-art, high-altitude, long-endurance RPV capable of runway takeoff and landing, either manually or automatically, under onboard computer control by following tactical landing radar beam and radar altimeter data. The Mini RPV is the first step in a new battlefield reconnaissance concept where the small size, low radar cross-section and relatively quiet propeller engine of the Mini RPV makes it ideal for over-the-horizon location of mobile missile launchers, tanks, and other battlefield equipment representing an immediate threat to frontline defenses. Like the Firebee target aircraft, RPVs can be launched from stationary or mobile zero-length ground launchers, or for long-range missions over remote areas. The primary launch method is by air from a DC-130 mothership. Here, the remote pilot controls or monitors the RPV mission and receives any relayed reconnaissance video or SIGINT data. Recovery is by parachute on land or sea and retrieval by land vehicle, boat, or helicopter. Where tactical conditions permit, a mid-air retrieval system can be used. Here, a helicopter captures the vehicle in mid-air by hooking onto its parachute and returns the RPV to the launch site for more rapid mission turnaround. More generally useful, however, is the airbag impact attenuation system, consisting of reusable airbags which automatically inflate prior to impact to prevent landing damage. The system can absorb the landing energy of a vehicle weighing over 1,500 kilograms. Teledyne Ryan RPV operations can be set up and conducted anywhere in the free world by experienced company technicians who can train the user's own personnel in all aspects of RPV operations and maintenance. With its unmanned aircraft capabilities, recognized as the most comprehensive in the aerospace industry, Teledyne Ryan Aeronautical is confident of another half-century of aerospace products and capabilities.